Okay, here it is. City and Guilds 2365, Level 3 Evening Course. As part of Unit 302 Electrical Science, you're going to have to complete a practical task on a transformer. Okay, so what we've done during these unusual times is set up a rig. Okay. And here's the setup we have for you. Okay, so we're going to start with the transformer. We've got 4 loads, which are just 4 spotlights with a one-way switch for each one of them. Okay, we've got a power analyzer, which basically measures voltage, current. Okay, and it'll measure the likes of watts, VAs, which are volt amps, and VAR, which are volt amp reactive. It'll also give us power factor of around 6 there, and it gives us a range of different things that you may need. Okay, not of too much interest to us at the moment. The other setup I've got here is just monitoring the input current. Okay, so on the right hand side, on the smaller of the multimeters, you can see it's about 0.17 of an amp. That's 170 milliamps. And you can see that the supply voltage at present is 242.7 volts. Okay, so obviously in the regs we say 230 volts. This is the voltage in my shed on a Sunday evening. Okay, so there's the setup. In terms of the practical, the plan is to basically just put on different loads and see what the output voltage of the transformer is going to be. Well, without any load on it, the voltage on the transformer is about 14.4 volts, or ms, for root mean squared. Okay, it's not pulling any current at the moment because there's no loads on. The input to the transformer, so the primary side on the bottom with the V on it there, is being monitored by these meters. So that's basically monitoring the voltage on the left, the current on the right for the input to the transformer. So what I'm going to do is I'm going to put on different loads. Okay, they're very bright, so I'll pop them on, but all we're really interested in is the readings on the output side, which is on the power analyzer, and the readings on the input side, which are on the multimeters. Okay, going to turn it sideways just to try and get them at the same time. And the first thing I'm going to do is just hit a load. Okay, so as I said, very bright. Okay. And we can now see that the voltage on the secondary of the transformer has dropped because you're pulling some current, and you can see the current we're pulling is 4.5 amps, 4.54 amps. And that the VA rating, the voltage multiplied by the current, is about 63 VA. The input voltage 242, and the current being drawn from the supply now is going to be 0.38 of an amp. So there's a piece. If you want to pause it at that point, that gives you your first set of results. Okay, let's pop another one on. Brighter again. On the output side, the voltage on the transformer has dropped to 13.42 volts RMS, and the current has doubled. Again, the VA rating has doubled to about 121. And in terms of the inputs, well, the voltage is remaining fairly solid, but the current drawn from the supply is about 0.6 of an amp. Let's go for a third one. Transformer has dropped again to about 12.97 volts. Okay, you can see the current is up over 13 amps and the VA rating has gone up again. You've got an input voltage of 242 remaining fairly solid, and the current being drawn from the supply is 0.854 amps. Let's put the last one on. The supply, or the voltage from the transformer, so the secondary voltage is 12.5 volts RMS. The current being taken from that secondary of transformer is about 17 amps. and you're on about 210 VA. The input taken from voltage from supply just dropped a bit to 241.5, and the current is just over 1 amp. Okay, so going to turn some loads off here. Okay. Now the point of the exercise is that the output voltage for the transformer is 14.376 volts when there's no load. Let's have a look and see what it is when it's full load. And it's now down to about 12.44 volts. Let's turn them off just so as we can see again. Okay, a transformer under full load, the voltage drops because you're pulling more current. Just like loading someone up with bags of cement. They're not as tall as they were when they had no bags. The more bags you put on, the more they go down. Transformer is exactly the same. So with full load, the voltage drops. With no load, the voltage will be at its maximum value of 14.378 volts RMS here. We do a calculation which is called load regulation for a transformer. So the transformer, one of the measurements is what's the output voltage or secondary voltage under no load minus the output voltage under full load divided by the voltage under no load. When we calculate this, we come out with a percentage regulation, and for this example it should be somewhere in the region of 14-15%. Okay, we'll have a look at that. Okay, so again, that's all I need you to see on the practical. It's run into 7 minutes, which is a bit long. Okay, but we'll give it a bash.